Welcome to this short video on the response spectrum analysis in Tekla Structural Designer. Tekla Structural Designer makes it easy to design your project per the response spectrum analysis for seismic forces. There are three basic steps to follow. First, run the design static command to design the structure for the static load combinations. Next, run the seismic wizard to generate the RSA data and RSA combinations. Finally, run the design RSA command to design members for the RSA load combinations. To demonstrate this, we'll use a 4-story concrete structure composed of beam and column systems with an interior shear wall core, as well as flat plate slabs. The concrete members will be designed to ACI 31811 and ASC 710. All of the gravity loads have already been added to the building: dead, live, and snow. The wind loads have also been added using the wind wizard to automatically generate the loads. Opening the generation combination box will show we have both gravity and lateral static combinations defined. Now we're ready for step 1 to run the static design for the existing load combinations. The show process log will run through all the steps the program is taking during this process. Once it's done, the program will switch to the review view, showing the design status of all members based on color coding. We can see all members are green for passing, so we're ready to move on to step 2. In the loading ribbon, we can now click on the seismic wizard command. This will walk us through inputting the necessary information for the program to calculate the seismic forces. Some of this information will be brought in based on the model. Other information you'll need to input as appropriate for your structure. Take note that the max earthquake spectral response acceleration factors are in percent gravity. This will then calculate the spectral response acceleration periods below and the seismic design category. Next is a checklist for the engineer to determine which procedure is appropriate for their model. You can go through and check if your building has any of these irregularities based on ASC 7. Depending on different combinations of irregularities, the program will tell you which analysis procedure is permitted. The code allows you to choose RSA for any structure, so choose this option to skip the step of checking for irregularities. Next, define information for the fundamental period used in the seismic force calculations. For the response spectrum analysis, the program will perform a full vibration analysis to calculate the building period. You must still input these additional parameters, and the approximate period will be displayed for your information. Now define the seismic force resisting system. These will determine the coefficients and factors used in the seismic calculations. The drop-down menus contain the options corresponding to the tables in ASCE. You can review the factors which are automatically generated below. You can also have the option to modify them as needed. This final page allows you to define which load cases are used to calculate the building mass and use in the vibration analysis. This is calculated automatically based on the cases you include to be converted to mass. Once finished, the program will now prompt you to generate the RSA combinations, which will be used during the design. Since I only have concrete design in the structure, I'm going to remove the ASD combinations and only generate the LRFD combinations. Note the factors are brought in as appropriate per the code, but you have the ability to change them here if needed. The next page sets the factors that will be used in the serviceability calculations for member deflections. Finish now completes the process. If we look at the combinations again, we'll see the seismic combinations are now included in this list. The third step then is to perform the design RSA. Seismic requirements are considered in addition to the static design. Therefore, it'll only ever increase the reinforcement as needed in concrete members. Once the design is complete, it's important that you carefully review the results. In addition to graphical results, you can also check the seismic report. In the report ribbon, we can open the seismic report. On the first page, it shows us the response spectrum data and the seismic base shear determined by the ELF method, and also the model base shear determined from RSA. The next page contains the seismic drift report, which lists results for every column in the model, and these are automatically calculated as well as the allowable values based on the code. In this example, all of the columns are passing. It is possible to get more information on the seismic drift and exactly how it's calculated by reviewing the tabular results in the Review view. Switch the view to Seismic Drift. Make sure the other parameters are set properly for your analysis. Then click on Details next to the column you want to investigate. In this Details screen, we can see the stack story drift, the actual and the limiting seismic stability coefficients, the allowable story drift, and pass-fail statements. We can also see tabular results for the vibration frequencies in the Analyze ribbon by clicking on Tabular Data. Switch to the result type for RSA seismic. Select the effective seismic weight from the loading toolbar. Now you can review the periods and the mass participation in each direction. Let's take a closer look at the graphical results. First, we'll look at what was actually generated by the program. You'll see we have a seismic RSA load case in each direction and a seismic torsion case. For the combination, there are two listings for a given combination, one in each direction, plus the seismic torsion. It's important to note that this combination of positive and negative values, and that this is actually an envelope combination. This becomes clearer when we look at the graphical results. Switching now to a results view of the building, we can select the RSA seismic analysis, one of the load combinations, and select to view the major moment diagram for the member, as well as axial forces in the shear walls. We can now see the forces displayed are for an envelope. We can also open a load analysis view for a particular member by right-clicking and choosing Load Analysis View. Select the result type to be displayed and the diagram required. We are now looking at the static results for this beam. We can change this to look at the static plus seismic result. We now see two additional lines that are plotted, one with static plus seismic forces and one with static minus seismic forces. The design profile shows the actual envelope being designed for. That concludes this short presentation on the response spectrum analysis in Tekla Structural Designer. For more information, contact our support department at support.us@tekla.com.